Given that the Earth alone is way larger than we think it is, what about the entire universe? Scientists have expressed its size in numbers, but those figures don't really do much for our imagination. In this video, we will explain why the universe is of mind-blowing proportions. Whoever came up with the name space really knew what they were doing. When it comes to the universe's origins, the Big Bang Theory has long surpassed other creationist musings. Evidence of this singular event that birthed all of space and time has been discovered over the years by numerous scientists in different places. If you're unfamiliar with the theory, it posits that 14 billion years ago, everything in the universe exploded into existence from a single point in space. There was an explosion of light and heat that gave birth to both matter and energy. Although much of this matter was hot and amorphous at first, it eventually cooled down, forming planets, comets, asteroids, and stars. But in the aftermath of the explosion, the universe continued to expand, making it bigger and bigger and bigger. The rate of expansion of the universe is calculated at 75 kilometers per second per megaparsec. This means that as time goes on, the faster it expands. This has even caused alarm among some schools of thought. Some scientists believe that the universe will eventually expand so much that the force of gravity cannot hold it together, rendering everything in cold darkness. When it comes to the actual size of the universe, well, you'd first have to define where the universe begins and where it ends. The fact of the matter is that, in the aftermath of the Big Bang, the universe has expanded so much that light, the fastest thing ever, is yet to reach our telescopes from out of deep space. And so, this limitation demands that the universe be defined differently. After all, you cannot clearly define what you have no conception about. And so, the term observable universe was spawned. This refers to a spherical region of space that contains all the matter that can be observed in space from Earth. To describe large distances which can be found in space, special units are used. And according to those special units, the diameter of the observable universe is 93 billion light-years in diameter. Despite what the name suggests, a light-year is a unit of distance and not a unit of time. It describes the distance covered by light in a single year of travel. Now, we have already established that light is the fastest thing in the universe, and given that light travels at 300,000 kilometers per second, a light year equates to 9.4 trillion kilometers. Now, does that figure mean anything to you? When you close your eyes, are you able to imagine it? As fascinating as the human mind really is, it has its limitations. When trying to imagine figures like that, you simply can't do it. Still, there are certain expressions we can use to try and imagine large sizes like those. They are mind-bogglingly large, but not inconceivably so. We expressed in pure figures, the observable universe is 93 billion times 9.4 trillion kilometers. This equates to a figure which is too absurd to print out. Mind you, this is just the portion of the universe that we can see. The actual borders may be far beyond that. In contrast, the moon is only about 300,000 kilometers away from the Earth. And even at that short distance, it takes about 3 days to reach the moon. You could fit 30 entire Earths in the space between the Earth and the moon. And so, imagine how many Earths you could fit between one edge of the universe and the other. Considering the moon again, whenever you look up at it, you're actually looking a second and a half into the past. This is because it takes that long for light bouncing off its surface to reach our eyes on Earth. The farther you look into the universe, the further you go backward in time. In the most extreme cases, the remnants of light that reach our eyes come all the way from the origins of the Big Bang 13 billion years ago. And this is only one universe. Certain theories exist which claim that there's a multiverse. If one universe is this mind-blowing in size, then how massive will a multiverse be if it contains multitudes of them? The scale of the universe is really too much for the mind to handle. So much that when we try to simplify it, those simplifications are, in themselves, too large for the universe to handle. Just know that space is so big for it to ever become crowded. As ironic as this sounds, the vast majority of existence consists of nothing. Coming to the end of this video, we hope you've gained an appreciation of just mind-blowing the scale of the universe. It's such a shame that the human mind can't really grasp the size, although pictorial representations go a long way to help. To learn more, check out other videos on this channel. Our content is always interesting and engaging, and you wouldn't want to miss out. Make sure to like, subscribe, comment, and share if you liked the video.